Hi everyone, welcome to your second set of missions, and these are about 2D graphs. Okay, so here's the mission. Pick one situation card, choose a graph card to represent it, and justify why to get your score. And in this case, the score is 1 sun or 1 point. Here's the situation: a bright day. The sky today in Santa Ana from 6 a.m. until 9 p.m. And the variable is brightness of the sky during the day, and it's varying with time. On the right, I have 4 graph cards, and we want to pick the one that best represents this situation. Okay, so, well, the situation is the sky today in Santa Ana from 6 a.m. until 9 p.m. We know that the brightness of the sky first will increase because sunset will probably be sometime soon after 6 a.m. And then the sun sort of reaches its peak, and then it's bright for a long time, and then maybe around, because it's closer to summer, around 7:38 is when the sunset happens, and that's when the brightness will decrease and eventually go to zero, maybe almost zero, because maybe there's the moon in the sky which will add to some brightness. Okay, so it looks like the first graph represents that situation somewhat, right? But just to be sure, let's consider the others and eliminate any options that do not fit the situation. Okay, so the second graph here, and actually all the 3 graphs, they end with the brightness being pretty high, right? The brightness is nowhere near close to zero in all the three, in the other 3 graphs. So certainly they cannot represent the situation because at 9 p.m. the sky is not bright. So this is quite easy. We can select the first one. Okay. Here's another activity. This is worth 4 suns now. And it says for each description A to D, plot an example graph. So here we are not matching graphs with situations, but we are plotting them by ourselves. And let's look at one of them. I grow slow. So I'm reading A now. I grow slow, then faster, and then slower and slower until I stop growing. Okay. So first, remember I'm growing. So as I draw my graph, it has to go upwards because I'm growing. But I first grow slow and then fast. So what will capture that? Well, first I'm growing slow and then it increases. So this kind of captures that, right? This kind of a shape. Um, and then I become slow again, but I'm still growing, remember. So I'm still going upwards, but I'm slowing down. Okay. So I'm growing, but I'm slowing down until I stop growing. So then maybe we can end somewhere here, right? Where I'm not growing anymore, I'm kind of level. And this represents the situation in A. I grow slow, then fast, and then slow until I stop growing. Let's look at B. I grow very fast, then slow down, reach my maximum value, and then start going down at a rate that does not change. Okay, so let's go step by step. I grow very fast. So maybe something like this would be a very fast growth. And then I slow down, okay, and I reach my maximum, something like this. And then I start going down at a rate that does not change. So what captures that? We know that lines capture constant rate of growth. So I'm going down at a rate that does not change. Okay, let's look at C. I grow a bit and then I start going down each time faster and faster. So I grow a bit and I'm growing faster and faster. So this captures that. And then I start going down again faster and faster. Uh, so at first I'm going down maybe slowly, and then my rate of decrease goes faster and faster. So this is what would capture that. And lastly, I grow very, very slow, and then I suddenly go down, and I repeat this pattern again and again. So I grow very, very slow, and then I suddenly go down. And then I grow slowly again, and then I suddenly go down. And then I grow slowly again, and I suddenly go down. And so on. So this would be the situation in D. Okay, so let me just abstract away from these specific situations to talk about rate of growth in general. Um, right. So first, there's two different things that we're talking about. We are talking about growth and decrease. So we are talking about our variable increasing versus decreasing, and we are also talking about how fast it is increasing or decreasing. So whether it's increasing or decreasing is captured by whether the graph is going up or down, right? This would be an increase, this would be a decrease, and this would be neither, constant. But let's now fix the situation to be a situation of increase, right? Let's assume increase. Or let me be more precise, let's say assume y increases with x. Now there are three situations I could be in within this situation, depending on how fast y increases with x. Okay, so either y could increase at a constant rate, so at a rate that is proportional to how, like the increase in x, and that would be captured by a line. So this would be constant rate of increase. Y could grow faster and faster as x increases, and that would be given by this convex graph, and this would be increasing rate of increase, right, at first. And how do we know that? Well, as x, suppose this is 1 unit of x. So what's happening here in this part of the graph? As x increases, say from 1 to 2, y increases, but just a little bit, right? The increase in y is, say, like maybe this is half unit. But let's look at what's happening in this other part of the graph. Suppose this is probably like something like 5 and 6. So as x increases from 5 to 6, the increase in y is much larger, right? This looks like maybe 1.5, 1.5 units. This doesn't happen for the first graph, right? Whether I calculate the rate of increase in y here versus the how much y has increased when x increases 1 unit here, it's the same. That's not the case with this convex graph. It keeps increasing. The third situation I could be in is a concave graph. This is when we have a decreasing rate of increase. So I'm still increasing, but at a decreasing rate. And we can see that again. If I calculate the increase in y with as x increases by 1 unit in the beginning part of the graph, that is quite large. But in this later part of the graph, it is much smaller. So I hope this gives you an idea for what's going on and also how to explain this idea of rate of increase to the students, right? This can get confusing for them. We are talking about two different kinds of increase and decrease. In the first case, we're talking about just whether y increases with x or not. And in the second case, we are talking about the rate of increase of y as x increases and the different graph shapes that capture each of these phenomena. Okay, so good luck with this activity, and I hope you have fun with it.